one thing I wondered, I looked at that table variable plan, the one that is really fast, and I said, what if I update fewer rows? One of the things with table variables, if it doesn't have that recompile hint, is it way underestimates how many rows are in there. So I was like, okay, well, instead of updating 800,000 rows out of a million rows, what if I only update 8,000 rows? Now, it is going to be faster just because I'm doing less work, but am I going to see that extra I/O in the execution plan? Let's test here and see. First, we're going to do our normal user database table with 8,000 rows. I'm saying execute with recompile because I'm saying I don't want to reuse the plan that's in cache for 800,000 rows. I want you to come up with a new plan, and also don't leave it around for anyone else to reuse. Just give me a special plan. That's why I'm doing exec with recompile. This takes 78 seconds to do, or 78 milliseconds, important difference there, to do the update. And of course, we're just updating far fewer rows, so it makes sense that it's faster than this used to be 1.5 seconds. Looking at my execution plan for the update, the user database table is now getting a narrow plan. Now we have a clustered index update. We don't have a separate operator finding the rows. We have a clustered index update that does have a seek predicate on it to find the 8,000 rows on it. Looking at how much I/O it does, the properties of our operator, we're doing 538 logical reads to find those 8,000 rows. So this looks like it's going to be our fast case again, right? Let's see how the temp table does. Running it again with recompile. And this, it doesn't take very long. We're not dealing with that many rows, but let's see if the I/O characteristics are different. Oh, this is looking good. I got a nice narrow plan here. I didn't get one step to find the rows and then one step to update the rows. Sometimes that wide plan is fast, but previously, for the temp table, it was slow. Looking at the properties of my clustered index update operator, we didn't do millions of logical reads. We only did 537 logical reads. This narrow plan, it looks like our temp table is much less pathological. It's not doing tons and tons of extra I/O when it has this narrow plan, at least for the case of 8,000 rows. That's interesting information. Gonna run table variable test, get a nice fresh plan for 8,000 rows. It also gets a narrow plan. It got a narrow plan before, so that's not anything new. Looking at the properties and the logical reads, we are at 537 logical reads again. What about, though, when we use a recompile query hint on the update of that table variable? Well, we're still at 79 milliseconds. Oh, this is interesting. We did go back to wide plan, that recompile hint. When it came to the temp table, it was like, okay, I'll go with a narrow plan. But for the table variable, we have clustered index seek here to find the rows broken out as a separate step. Our actual I/O statistics, it's not just 537, that's 24,537. And then on the clustered index update, are we doing more I/O? Looking at the IR there, oh, we're doing another 24,000 logical reads there. So this is still pretty fast because we're only dealing with 8,000 rows, but the pattern of extra I/O that at some scale leads to slowness, that pattern is still happening for the table variable when we update it with a recompile hint. What if I only update one row for the table variable? I've still got my recompile hint in there. I'm not doing 8,000 rows. I am simply updating a single row. I still get my wide plan for that. And let's just for fun, let's look at the IO that we see on it. For the clustered index seek, my actual IO statistics are 7 logical reads there. And that's not that many, but it is kind of just interesting to see how many we get. And then we get 3 logical reads on the update as well. So definitely, not too terrible to live with when you're updating one row, but that pattern that at scale gets slower and slower and slower, where we have this inflated IO on multiple operators, is still happening even at a small scale when we're using a table variable as well as a recompile query hint.